In this video, we'll discuss factors on which the resistance of a conductor depends. As we know that every metallic conductor having a resistance. What do you mean by resistance? Resistance is the property of a conductor to oppose or restrict or resist the flow of charges in that conductor. That property we are calling resistance of that conductor. Okay, so that resistance depends upon what factors of the conductor we are discussing. For that, let us have activity 12.3 as shown here. What is this? This is a circuit where we have a battery, a plug key and an ammeter. Okay, connected as shown here. And here we have two terminals which we made a gap. Now we are going to connect these four types of conductors. Let us have the nichrome conductors here, which having a different length and the thickness. First we took a nichrome wire of a fixed length. We connected here nichrome wire. After connecting, by switching on this battery, whatever reading on the ammeter we are observing and written here. Okay. So this nichrome wire connected here by switching on the battery, whatever reading by ammeter we written. Next, by changing this wire and connecting this second wire, which is having a double length of this nichrome wire, connected here and switching on the battery and observing the ammeter reading, and we written here the ammeter reading 6 ampere shown by the ammeter by connecting this nichrome wire. And again we are now changing this nichrome wire of a double length into nichrome wire of the same length, but the thickness of the wire is more than the earlier one. Okay? Thicker wire we took here, but the length is same. Now we switch on the battery by the plug key, and by observing current in the ammeter, we written here the current reading for this thick wire which is connected here. Okay? Lastly, we took the copper wire of the same length which took for nichrome. Okay? And connected here by switching on the battery, whatever ammeter reading we written here. Okay? Observe all the current values here. We have different ammeter reading, different current values. What it means, due to length, due to thickness and due to change of material, we are having a different current. Okay? Wherever more current, it means that material showing or that conductor showing less resistance. Wherever less current, that material showing more resistance. Now compare this nichrome wire and this nichrome wire. Compare this reading of ammeter. For this nichrome wire we have 12 ampere. For this nichrome wire we have 6 ampere. Means when the length increases, the flow of conductivity decreases. See here, from 12 to 6 ampere. Here less ampere, less current we are getting. Here more current we are getting. Means when the length increases, conductivity decreases. Okay, in other sense we say when the length increases, the resistance also increases. Length increases, the resistance also increases. Means the length of the conductor directly proportional to resistance. More is the length, more is the resistance. When more is the resistance, the flow of conductivity is less. Therefore we are observing this type of value here. Okay? So resistance depends upon length of the conductor. Now observe this nichrome wire and this nichrome wire. Okay? Length is same but thickness is more. Here the cross section area of this third one nichrome wire of the same length is more. Cross section area like this, which is more. Okay? This cross section area thicker. And observe the values here. More current for this, less current for this. What it means, when the area is more, the flow of current is more also. When the area cross section area is less, the flow of current is less. Means the resistance for this nichrome wire is more resistance. This nichrome wire showing compared to this nichrome wire showing less resistance. Hence the more current we are getting. Here the resistance showing more, hence the current flow of current in that conductor is less here. More resistance, less current. Less resistance, more current. What it means? Resistance of conductor is inversely proportional to cross section area of the conductor. Means more is the area, less is the resistance. Less is the area, more is the resistance. As the resistance changes, current also changes. Okay? So resistance depends upon which factor? Cross section area of the conductor. More area, less resistance. Less area, more resistance. Resistance changes, current also changes. Okay? So next, by changing the material, since we used here nichrome, instead of nichrome, suppose we used copper here, means material get changed, then also conductivity also changed. What it means? The resistance of a conductor also depends upon nature of the conductor. What material you are using for the conductivity, on that material also the resistance depends. So for different material showing different resistance. Okay? So third factor is what? Nature of the material. Nature of a material. What conductor or what type of material it is, copper, aluminium, whatever. Okay? So we conclude what? Resistance of a conductor is directly proportional to length of the conductor. Means length increases, resistance increases. Resistance of a conductor is inversely proportional to cross section area of a conductor. Area of cross section area of a conductor increases, the resistance decreases. Cross section area decreases, resistance increases. Okay? Or which the third factor is nature of the material. Nature of material means different metallic conductors showing different resistance. Okay? Okay, so we can combine these two equation into one, that is R proportional to length, R inversely proportional to area. Okay? By removing this proportionality constant, we'll write here some constant. Okay? Okay, and A. This we'll read this symbol, Greek word, as a rho. It means it is a constant for this equation. We are calling this rho as a resistivity. Resistivity. Resistance is different, resistivity is different. Resistivity in the sense, for a unit length and unit cross section area, how much the conductor showing resistance, that specific resistance we are calling a resistivity. I will repeat. Resistivity is a specific resistance of a conductor for a unit length and a unit cross section area. Okay? For example, R is equal to rho. When R becomes rho, when L becomes 1 and A becomes 1. Okay? Unit length and a unit area, then we get what? R equal to rho. So we define what? Rho or resistivity is what? Specific resistance of a conductor for a unit length and a unit cross section area, what we are calling resistivity of a conductor. Hence it is one of the quantity of the conductor for the fixed length and fixed cross section area. The conductor showing a specific resistance, that specific resistance is called a resistivity. Hence we have, it's a SI unit. Okay? Let us have the SI unit here. R is equal to okay, we can modify the formula like this. R equal to rho L by A is there. Okay? We can convert into rho also. Rho equal to R A by L. Okay? So this is what? Resistivity of a conductor. Okay? Now what we are doing, we are finding a unit, SI unit. What is the SI unit of resistance? Ohm. What is the SI unit of any area? Meter square. What is the SI unit of length? Meter. This meter cancel, this cancel. What we are getting? Ohm meter. So SI unit of resistivity is what? Ohm meter. Ohm meter is the SI unit of resistivity. Okay, resistance is different, resistivity is different. Resistance is only the property of conductor to resist the flow of charges, where resistivity is the specific resistance for a given length and given cross section area. Unit cross section area and unit length, they have specific resistance. That resistance of conductor we are calling resistivity, and it having a different unit, that is ohm meter.